You are welcome to Educational World. In today's video lesson, we'll be looking at a simple experiment on triangular prism. But before we proceed, someone would like to ask, why do I need to watch this video? What do I stand to gain at the end of this lesson? Why will I waste my time to concentrate in all this rather than performing the real practical? But I will say, when you pay close attention to all that I will be teaching, you can be able to perform your practicals in far lesser time than expected. You will also be able to get more accurate results. And lastly, you will be able to know the mind of the person that said the question, because this is the secret they wouldn't want to let you know. Let me read through the instructions. You are provided with a triangular glass prism, 4 optical pins and other necessary materials. Place the triangular glass prism on a drawing paper and draw its outline UMR. Remove the prism. Measure and record the value of the angle at U. Draw a normal to the line UM at N. Also draw another line TN to the normal such that the angle phi is 60 degrees. Fix 2 pins at P1 and P2. Replace the prism and fix 2 other pins at P3 and P4 such that the pins appear to be in a straight line with the images of the pins at P1 and P2 when viewed from the side UR. Remove the prism. Join points P3 and P4, producing the line to meet TN produced as Z. Draw the normal XY. Measure and record the angle of emergence E and that of deviation D. Repeat the experiment with phi as 55, 50, 40 and 35 degrees respectively. In each case, measure and record the corresponding values of E and D. Tabulate your readings. Plot a graph with D on the vertical axis and E on the horizontal axis, starting both axes from the origin. Join your points with a smooth curve. From your graph, obtain the minimum deviation dm and the corresponding angle of emergence em. Hence, calculate the refractive index n of the prism using the formula given. Pay close attention in this section. If you miss this part, you've missed it all. Now recall that the value of the refractive index of a glass block is given as 1.5, and the formula for the refractive index is sine I, that is sine of the angle of incidence, all over sine of the angle of refraction. And the angle of incidence here is the angle that is made with the vertical, as shown, while the angle of refraction here is the angle also made with the vertical but inside the glass. So phi is not our angle of incidence. So when phi is equal to 60 degrees, our angle of incidence really is 90 minus 60, which is 30 degrees. Do you get that? Then putting it into our formula, we now have that 1.5 is equal to sine 30 over sine r, which we don't know. And evaluating for r, we now have that r is equal to 19.5 degrees. Now, there is something important I want you to note. Angles. The angle of incidence I is equal to the sum of the angles r, which is the angle of refraction, plus alpha. Reason, they are vertically opposite angles. So we can now find alpha from that expression. We now have that 30 is equal to 19.5 degrees plus alpha. Hence alpha is equal to 10.5 degrees. Very important. Now, we have to evaluate for R1. There is something I want you to take note of. Since the triangular glass prism is equilateral, the internal angle made there, as you can see, is 120 degrees. It is always 120 degrees. Don't forget that. Since the sum of the angles in a triangle is equal to 180 degrees, hence R1 can be found to be 180 minus 120 minus 19.5 degrees, which gives us 40.5 degrees. Then using the formula for our refractive index, which is sine of the angle of incidence all over the sine of the angle of refraction. Now the angle of incidence here is the angle of emergence, E, while the angle of refraction is already our R1. So we now put it into the equation. 1.5 is equal to sine E over sine R1, which is equal to sine E over sine 40.5 degrees. Then looking for E, we said that sine E is equal to 1.5 sine 40.5, which is equal to 0.9742. Therefore E is equal to 76.96 degrees. Then the same thing that happens with the former one, E, the angle E is equal to R1 plus beta. Reason they are vertically opposite angles, and from there we can now evaluate for beta. So we now say that 76.96 degrees is equal to 40.5 degrees plus beta. So what will be beta now? Beta will now be what? 76.96 minus 40.5, which is equal to 36.46 degrees. So the angle of deviation which we are looking for, which is D, is simply the sum of alpha plus beta. Reason, because the external angle of a triangle is always equal to the sum of the two opposite internal angles. So we can now say that the angle of deviation D is equal to 10.5 plus 36.46 degrees, which is 46.96 degrees. So we've gotten our angle of deviation. Now we move straight to computing our table of values. We can now say that when phi is 60 degrees, the angle of emergence is 76.9 degrees and the angle of deviation is 46.9 degrees. When phi becomes 55 degrees, all the processes we've gone through before repeats itself again. So we have that the refractive index is 1.5 and is given by the formula sine of the angle of incidence all over the sine of the angle of refraction. And I have told you what the sine of angle of incidence is and that of the refraction is. Okay, now when phi is 55 degrees, the real angle of incidence will now become 90 minus 55, which is equal to 35 degrees. And substituting that into the equation, we have that 1.5 is equal to sine 35 over sine R, and evaluating for sine R, and sine R is now equal to 0.3824. Therefore R itself is now equal to 22.48 degrees. Now from what we said previously, the angle of incidence I is equal to the sum of the angle of refraction plus alpha. Reason they are vertically opposite angles, hence alpha will be 35 minus 22.48, which is equal to 12.52 degrees. So we now move over to evaluating for R1. R1 is now equal to 180 minus 120 minus 22.48 degrees, which gives us 37.52 degrees. Why? Because these are all angles in a triangle. Now using the formula that n is equal to sine of incidence all over sine of angle of refraction, we will now have that 1.5 is equal to sine E all over sine R1. Okay, so we'll be evaluating for sine E. Sine E is equal to 0.91356. Then E, the angle E is now sine inverse of 0.91356, which is equal to 66 degrees. Now recall, vertically opposite angles are equal, so the angle E is equal to the sum of R1 plus beta. So we can now say that beta is equal to 66 degrees minus 37.52 degrees, which leaves us with the value of 28.48 degrees. So beta here is equal to 28.48 degrees. Just like I said earlier, the external angle of a triangle is equal to the sum of the two opposite internal angles. So the angle of deviation D is equal to alpha plus beta, which gives us 12.52 plus 28.48, which is equal to 41 degrees. Computing our table of values, we now have that when phi is equal to 55 degrees, the angle of emergence is 66 degrees, and the angle of deviation is 41 degrees. Very important. So we now move over. When phi is now equal to 50 degrees, the same procedure follows suit here. Okay, recalling our formula that sine of angle of incidence all over sine of angle of refraction is equal to the refractive index of a glass block, which is equal to 1.5. And I have showed you what the angle of incidence and the angle of refraction is. So we'll now substitute this into the equation. But before that, we will now say that when phi is 50 degrees, the angle of incidence, the real angle of incidence, is equal to what? 90 minus 50, which is 40 degrees. And putting it into the equation we have and simplifying for r, we will now have that the refraction, the angle of refraction, is really 25.37 degrees. From what we have done previously, the angle of incidence, is equal to the sum of the angle of refraction plus alpha, because they are vertically opposite angles. Hence alpha is equal to what? 14.63 degrees. So here now, evaluating for R1, considering the triangle there, the angles in the triangle, R1 will be equal to 180 minus 120 minus 25.37 degrees, which leaves us with the value of 34.63 degrees. And using our formula, N is equal to sine I over sine R, which you now have that 1.5 is equal to sine E over sine R1, sine E over sine 34.63 degrees. So evaluating for E, we now have that E is equal to what? 58.47 degrees. And from the fact that vertically opposite angles are equal, we have that beta is equal to 58.47 degrees minus 34.63 degrees, which leaves us with the value of 23.84 degrees. Then the angle of deviation D is now equal to what? Alpha plus beta, because the external angle of a triangle is equal to the sum of its two internal opposite angles. Hence deviation D is equal to what? 38.47 degrees. Computing our table of values, we now have that when phi is 50 degrees, the angle of emergence E is equal to 58.5 degrees, and the deviation is equal to 38.5 degrees. The same procedure goes on and on when phi is equal to 40 degrees. Now recalling our formula that sine of the angle of incidence over sine of the angle of refraction is equal to 1.5, and I've shown you what the angle of incidence here is and the angle of refraction here is. Now when phi is equal to 40 degrees, what really happens here is that the real angle of incidence is what? 90 minus 40 degrees, which is equal to what? 50 degrees. and putting it into the equation, we have that 1.5 is equal to sine 50 over sine r, and sine r is now 0.5107. Evaluating for r itself, which equals to sine inverse of 0.5107, we have 30.71 degrees. Considering our vertically opposite angles, we will now have that I is equal to r plus alpha. Hence, alpha is equal to 50 minus 30.71, which is 19.29 degrees. Now we have to evaluate for our R1. Considering the triangle we have there, the angles in that triangle, R1 can be found to be 180 minus 120 minus 30.71 degrees, which is equal to 29.29 degrees. Using the formula sine I is equal to sine R, sine I all over sine R, sorry. We now have that 1.5 is equal to sine E over sine R1, and evaluating for E, we have that E is equal to 47.21 degrees. Now note that the vertically opposite angles are equal. Now E is equal to R1 plus beta, hence beta here now is equal to 47.21 degrees minus 29.29 degrees, which leaves us with the value of 17.92 degrees. Now the angle of deviation D is equal to alpha plus beta. I've given you the reason. So we have that D is equal to 19.29 plus 17.92, which leaves us with the value of 37.21 degrees. We move over to computing our table of values. So we now see that when phi is equal to 40 degrees, the angle of emergence E is equal to 47.2 degrees, and the deviation is equal to 37.2 degrees. The same procedure goes on when phi is equal to 35 degrees. Still using our formula, n is equal to sine I all over sine r, indicating that where our sine I and our sine r is. So when theta is 35, when phi is 35 degrees, the real angle of incidence I is what, 90 minus 35, which is equal to 55 degrees. And substituting the value into the formula we have and simplifying everything, we will be left with R equal to 33.1 degrees. Now vertically opposite angles being equal, hence I is equal to R plus alpha, hence 55 degrees is equal to 33.1 degrees plus alpha, therefore alpha is equal to 21.9 degrees. Then moving over to solving for R1. R1 is part of the angles in the triangle. We now have that R1 is equal to 180 minus 120 minus 33.1 degrees, which leaves us with 26.9 degrees. Using our formula, general formula, 1.5 will now be equal to sine E over sine R1, and putting in the value of R1 there, we now have that sine E is equal to 1.5 sine 26.9 degrees, which is equal to 0.6786. Therefore, E is sine inverse of 0.6786, which is equal to 42.74. And simplifying for beta, because E is equal to R1 plus beta, hence beta here now is now equal to what? 42.74 minus 26.90 degrees, which gives us 15.84 degrees. The angle of deviation here now becomes alpha plus beta, which will now be 21.9 degrees plus 15.84 degrees, which gives us 37.74 degrees. So we compute our table of values. When phi is equal to 35 degrees, E, angle of emergence, is 42.7, and the deviation D is 37.7 degrees. So we have computed all our table of values, and you can see the uniform number of decimal places that we have so your table of values must have uniform decimal places. Then we plot the graph of D against E. It's gonna be a curve. Okay, the graph is gonna be a curve. As you can see, the graph of deviation D against the emergence E is a curve, and the lowest point of that our curve is the point of minimum deviation, which we have the value to be 37.2 degrees, and the corresponding angle of emergence EM is equal to 47.46 degrees. Now we substitute it into the equation we have to find the refractive index. Putting it into that equation, we now discover that the refractive index is 1.5. Can you see that we rewrite all this while by using 1.5 as the value of our refractive index, and this is how accurate you can be. Please, if you have any questions and need more clarifications, you can put your comments below in the comment section and I will attend to all your questions. Thank you for watching.